Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hi, everybody. My name is Gabriela de Queiroz, and I'm director here in California, San Francisco. Today, I'm excited to be talking to the founder of the AI startup, Wallaroo. But before we kick off this conversation, I want to invite you to join me here, this live bi-weekly show on YouTube. On this live stream, I'll be chatting with AI founders from top startups doing innovative work. We'll talk about their company, the product, the technology behind, use cases, customer stories, and of course, how Microsoft has been helping them in their journey. During this conversation, you can ask questions in the chat, and I'll be selecting some of them to be answered live. And before we start, let me share this amazing program that we have here at Microsoft. We offer startups, no matter where you are in the journey, up to $150,000 in Azure credits that can be used in our latest products or different generative AI models like the models from OpenAI. You also get access for free to 30 plus tools and services to help you grow and scale. And on top of that, you get free one-on-one sessions with Microsoft experts to work through technical and business challenges that you might have. And today, for the episode number 5, I'm excited to have Vid, founder and CEO of Wallaroo. Vid, welcome in to the show.
Hey, Gabriela, thanks for having me as part of this. I'm excited to talk about what we're up to and what our journey was like.
Awesome. So let's start by the company itself. Before that, can you walk us through like your journey? Because you have a long story of like different companies and different things that you did. You also have a PhD in physics and bachelor in computer science. So, and worked in several companies as a founder, co-founder, worked on the financial industry for a long time as a trading type of job. So can you walk us through like your background until to the point where you're like, okay, this is the company that I'm going to found, and the reason why I'm founding this company is X.
Yeah, no, thanks a lot. Yeah, I guess you know more about me than I realized. Okay, so yeah, as Gabriela said, I came out of academia, a PhD from UC Berkeley, but you know, I did have a couple of startups, but I think the background that's most pertinent to what we're doing now is really I spent 9-10 years helping to build the high frequency trading business at Merrill Lynch. I started at Morgan Stanley and then ended up at Merrill Lynch. And then, you know, high frequency trading or automated trading is really sort of AI before anybody called it AI. Massive amounts of data. It wasn't just high frequency time series data, trade data and pricing data, but we looked at any kind of data that we could get our handle on, even looked at things like Twitter feeds, et cetera, SEC filings. And the idea there was to use that data to make money, obviously, but also to make money without taking undue risk. So obviously, you know, you can do all sorts of crazy bets, but you want to also understand what the risk implications are for those trades that you're doing. And so we had folks that we call quants. They weren't data scientists or ML engineers. That's not what we call them, but they were kind of, again, the precursor to those kinds of roles. And they were developing all sorts of these strategies for trading and for managing risk. and those strategies were encoded in code that we ran in not only our data centers in New York, but because of the fact that this was an arms race, and in some cases it was a race against the speed of light. Oftentimes you couldn't bring the data to your algorithms. You had to take the algorithms to the data, right? So for example, if you're trying to trade on the London Stock Exchange or the Singapore Stock Exchange, or even something in Chicago, bringing that data to New York, running some kind of algorithm on it and sending the result back, you're always going to lose. So we had to innovate in quite a few different ways, massive amounts of data. We had to understand, we had to develop these algorithms or strategies against that data. We had to figure out how to deploy them efficiently and quickly. We spent massive amounts on infrastructure. So trying to figure out how to reduce the infrastructure costs while keeping the latency low. And we're really talking about making a decision and executing a trade in, ideally milliseconds or even less than a millisecond. That all became a set of challenges that we had to solve for. And then obviously you're running a business with a lot of money on the line. And so you can't go blind. You can't be like, oh, let me let this thing go off and trade for a week, and I'll come back and see if I made 100 million or lost 100 million. So we had to solve a lot of challenges that when I left Merrill Lynch, I realized as everybody started talking about AI in different industries, whether that was manufacturing or retail or aerospace or advertising, that these set of challenges were ones that, in fact, we had spent a lot of time and energy solving for. And so that was really sort of in 2018, the genesis of Wallaroo was, hey, as AI becomes increasingly important to enterprises, they're going to need a similar set of tooling for deploying, for managing, for monitoring AI in a quickly, efficiently, and low cost. So that's really sort of the genesis of Wallaroo. And then luckily for us, at some point, Microsoft paid attention. They're like, oh, what are these guys doing? This sounds interesting. And became one of our leading investors a couple of years ago.
That's awesome. So the company was founded 2018, so it's been more or less 6 years. And I know that you have some slides to show us so people can understand a little bit more. And you have a demo as well, which I'm very excited because I haven't seen the demo. Do you want to go and share so we can get some insight of like what Wallaroo do? And also for the audience that is listening in and watching us, if you have any questions, don't forget to ask questions and we'll be answering those questions live.
Okay, thanks. So before I dig into the slides, I just want to maybe spend a little bit more time because, you've heard kind of like the original thesis around Wallaroo, but a lot has changed in the last 6 years. So I do want to maybe talk about a little bit about the evolution and sort of what we're solving for now. It's no different, I think, conceptually than where we started. But again, a lot has changed. The types of models, the use cases have evolved. Obviously, two big trends have impacted us in the last year to 2 years is really around edge computing and then generative AI. So I just want to talk about that. And I think, one thing to say is we started in 2018, but what we quickly realized is there was a lot of talk about AI back then, but not a lot going on. People were mostly still trying to figure out their data. How do I clean this data? How do I make sense of the data? How do I build a data lake? How do I, and so the AI journey really starts with data. It goes to like, okay, I need to have a model or two models or some algorithms that can act on this data in a live online setting. And then you've got the third leg, which is really inference. And so, where we're focused on is that last leg, the inference leg. And so it has taken, I would say, we started building product in 2018. And what's happened, though, is that the industry has taken a while to get to where we were focused. And this last year in particular has been, I would say, an inflection point in terms of inferencing, right? In terms of like more and more, it used to be like 80% of people we would talk to be saying, hey, I'm still trying to cleanse my data or organize my data. And then we kind of got to the point maybe a couple of years ago, people are like, oh, okay, I got this open source model, or I have some data scientists and they train some model for pricing or recommendations. And more recently, hey, I took this, I'm doing some stuff with some of the generative AI stuff. But really, it's really only been in the last year, maybe even the last 6 months, that there's all of a sudden a pivot or an explosion in folks interested in inference. And that's, another way of saying that is really the operationalization of those models and of that data into something that's going to create business value. And, this is not just us experiencing this, but it's also, you can see it in companies like NVIDIA. You can see it in, even Microsoft, that there's a much more pressure, or there's much more desire for enterprises to actually operationalize those AI and turn them into business value, right? And so that's great for us. I think our business has taken off in that sense in the last year in a big way, but also we're learning a lot about the market. We like to be close to the market. We have partnerships. It's not just enterprise customers, and we'll talk about some of those in a little bit, but we have partnerships beyond just Microsoft. We partner with Oracle, with Intel, with IBM, with a few others that we're going to announce. So all that gives us a lot of eyes and ears in the market. And, and what we're seeing is that there's an explosion in different kinds of use cases. And what we're seeing with our customers is they have some level of success with AI. They have one or two models that are delivering business value. It might be for marketing, for personalized ads, or for recommendations, or it might be forecasting for a retailer, or it might be some kind of customer support in healthcare using generative AI. But they get a couple of things working really well, and then they double down. Then they're ready to scale. So the biggest growth that we're seeing is really that while most enterprises are still kind of, not quite at that, let me scale my AI, we're seeing more of those AI success stories where AI teams and enterprises are wanting to suddenly go from 2 or 3 models to 10 models to 25 models to 100 models in production. And so you've got that trend. You've got the other trend, which is really that it's not just necessarily about a single cloud. It's about multi-cloud, or it's about, hey, I want to go from Azure to the edge, or I want to go from Azure. I want to train in Azure, for example, or it could be one of the other clouds, and I want to deploy on-prem, right? So the complexity of the environments is also getting much more interesting, and then the third thing, obviously, in the last few months, you've seen a lot of talk about agentic AI, right? Where people are wanting to essentially, the simple way that I think about that is you have multiple different steps or models or tasks that are working together to produce an outcome or an actionable piece of information. And so all of that, when you put it all together, more and more types of use cases, more and more complex environments where you need to deploy to more complex workflows involving multiple models running. When you put that all together, you've got this huge explosion in complexity, right?
Right.
And then the other trend that I think is really, we're noticing very heavily, is really the trend of more and more types of models. So I think DeepSeek was interesting because in my mind, what DeepSeek showed is that there's less moat around some of these models that people expected, and so I believe DeepSeek really demonstrates that there's going to be a lot more variety of models, and maybe even more specialization around a model. So there's going to be more models that people have to choose from for what they want to do. And at the same time, there's an explosion of infrastructure options. So while everybody is obviously, the default thing seems to be, let me deploy a model to NVIDIA GPUs, we're seeing more and more people trying to see if some of those use cases can't be deployed onto other kinds of GPUs, AMD GPUs. Intel has their own stuff coming out. With IBM, we're working with them to help their customers deploy onto the IBM Power architecture. So when you put that all together with the use cases, agentic AI, and then you've got more varieties of models that you can work with, and all this infrastructure variety, that's a lot of complexity to go from, hey, I have an idea of how to make more money or how to make my operations more efficient. I can test this in some testing environment. I can validate it. Now I need to actually deploy it at scale in production, keep it effective day after day. That's becoming an immense challenge, right? And so the reason I kind of giving this background is because we're exactly, we started this journey with Wallaroo 6 years ago, but we're seeing is that the market is finally getting to the point where it's the use cases and the infrastructure and the models, that combination is reaching that kind of complexity phase where people, your option is basically throwing engineering resources at it and throwing infrastructure at it, or is there a different way? And so that's really where we come in. Is we have a product, and I'll go through some of the slides around the product. But we have a product, we call that product the Universal Inference Platform. And what it is really designed for enterprises to take these complex workloads, AI workloads, and operationalize them in a way that's easy, that's fast, that minimizes the amount of engineering time, minimizes the amount of infrastructure, and then helps them keep them effective day after day. And one other thing I'll say before I go to the slides and we go to the demo is our perspective is who are the people doing the work? It's the AI developers, right? It's not the CFO, it's not the CIO, it's not the COO, it's the data scientists, it's the ML engineers, it's the ML ops person, it's the DevOps person. Sometimes there's like a software engineer that's being pulled into the ML space. So these are the people that are actually the heroes. These are the ones that are doing the work. These are the folks that are going to make this a success or not. And so we've been very cognizant from the beginning that we are building tooling for these people. This is not some dashboard the CIO looks at. This is not some thing that after the fact runs the report, right? This is to make the lives of AI developers and the variety of these folks and with different skill sets, to make them their lives better, to let them focus on what they're good at. So very often we see data scientists getting pulled into infrastructure stuff.
Yes.
Right. That they don't want to do. Some of them are actually really good at that. Some of them can be good. I'm not saying that, but that's not what they were hired to do. That's not what they find exciting. They don't want to deal with infrastructure. Right. At the same time, sometimes you see the ops people or the engineers having to understand some Python code, which does some kind of pre-processing before it goes in the model, and so they're pulled up the chain, and then all of a sudden the whole thing becomes like spaghetti,
Yes.
and meatballs that's like somebody's put in a blender, right? And so our job here also is not only to give these folks tooling that makes them kind of as a force multiplier for what they do, but also lets them really focus on what they want to do. So the data scientists can focus on things that they're really good at and things that they understand. They don't have to think about, how do I package this up? How do I make sure this runs on 6 GPUs instead of 1 GPU? How do I like I don't want to deal with any of the infrastructure or the middle layer. And at the same time, how do you give people that are more engineering or ops related, how do you abstract away that stuff that they don't want to deal with, that they don't want to understand? Like, I don't need to understand that this consists of 3 different models that are coordinating this way. I just want to basically deal with standing up some Kubernetes thing or deploying a Docker container. Like, that's the stuff that I'm good at. That makes it simple. If I have to understand all this other stuff, then I'm not going to be good at my job, and I'm going to be fast, and it's going to be slow and complicated. So
Yeah.
really, that's kind of where we're approaching it from. So I'll stop there. Yeah.
No, I loved it. It was like a real like lecture in the way of like the whole progress of like the big data, and then we didn't have enough data, and then we have tons of data, and then all the evolution to we get to where we are. And it's also like interesting what you brought up about the data scientist, because I am a data scientist, so everything that you were mentioning I can relate. And it's also like for the audience, I know that we have some data scientists, AI developers. It's good for us to hear that there is this place where we can succeed and do our best using what you can offer, and not being worried about the other pieces that it might be not the best use of our time. And the other piece that I feel like it's interesting that you talk about all these models that are being deployed and in production. So now infrastructure, the AI workloads. So tooling for the people, I think that's something that I got as well. It's a great
tooling for the people. Yeah.
Tooling for the people. Yeah, I really enjoy what you said. Tooling for the people. I'm going to use that one. So let's go and do a deep dive of like what you have on the slides and demo, and then we can keep talking. But thank you for giving us like the evolution of because some people don't know what happened in the past, right? They think that all of the things that we have now, it's been there for a long time. And no, it's been an evolution to get to where we are.
Yeah, I think it's an evolution to get where we are. But the other thing I'm seeing is that things are not standing still. Things are actually moving ever faster. So people, even if they built their own internal processes and built up an engineering team, they're understanding that actually they can't keep up. And so that's the other problem that this rapid rate of change is, the fact that people get to a point where they have a handle on something, and then somebody throws a new thing out there, and then they have to go deal with it. So yeah, let me hopefully this will work. I will share my screen. Enter screen. Okay. All right. So let me start here. And I know I'm supposed to. Can you see this?
I can. It's loading. Yes.
Okay. All right. So this is kind of what we call our product. It's we're software, first of all, right? We're software tooling for the people, as we said. But we're really focused around the inferencing. And one thing is to clarify here is when we talk about our software, we're talking about what we call an inference platform versus just like an inferencing server or an inferencing engine. And that's because what we found when we started this journey a few years ago is we started with focusing on the inference server itself. We were going to build the highest performance, the most flexible, the lowest cost piece of software for doing any kind of inferencing. And we built this inference server in a language called Rust. And we use all the tricks of the trade that I know from my high frequency trading days, but also we have people here that came from high performance computing and other areas. So really, how do you build like highly optimized code for running models on data and providing all those inference services? So we got that down really well. I'll show you in a slide or two that from a performance perspective, this really is super performant. But what we realized over the course of the last 2 or 3 years working with partners and customers is that's really not sufficient to operationalize enterprise AI. So because um, the inferencing has to fit within a enterprise workflow, and it has to integrate into an enterprise ecosystem, right? So the two other pieces that we actually are part of our inference platform. One is our integrations toolkit, and this integrations toolkit allows us to integrate into different data science and training environments, into different data environments, into different cloud and on-prem environments. And so the idea is to give the AI developers a kind of seamless path. They don't have to get out of the environments where they're comfortable in. That could mean they're working in Databricks or they're working in Azure ML. I don't know if I'm allowed to say it here, but some folks are also working in SageMaker, Amazon SageMaker, or other GCP Vertex. And so, and they're working with different databases, different vector databases, different time series databases, different real-time streams of data. Maybe they've got Kafka. So one is this integrations of toolkit that we have that allows us to integrate into pretty much any kind of environment. And then the second thing that we realize is really important is people need a command and control. So again, if you've got one or two models deployed, okay, fine. But we've got customers that are rolling out to 4,000 edge locations. So you've got customers that are deploying 100 different models in the cloud, and some of those are now going on-prem. So you need to be able to see from a central spot how everything is running, what the version history of things are, how do I update a model, how do I look at how models are doing. You need a sort of command and control. And this is not to take away from cloud native solutions, Azure and SageMaker and some of these other folks have some of this already. But this is really when you start scaling out and start entering hybrid environments and start having things like agentic workflows where you have to see the entire pipeline and how it comes together instead of just pieces of it. So over the course of a few years, we realized that really success for enterprises means these three things. It means very high performance, flexible inference engine, right? It means an integrations toolkit, which allows me to integrate into any kind of enterprise environment. And then this operations center that gives me a centralized view of what's going on. So these are the three things. If you think about it, where does this stuff run, right? So all this stuff is really a bridge between the models. These models could be any kind of model. They could be random Python code. They could be the latest, greatest models. They could be standard machine learning stuff. They could be computer vision models. We don't care what they are. And so you've got, on the one end, you've got these models and these data and data science environments that folks work with. And then on the other hand, you've got infrastructure, which is where this stuff needs to run. That infrastructure is composed of a variety of hardware, AMD, Ampere, which is ARM CPUs that you have in Azure, IBM, Intel, etc. NVIDIA, obviously, Qualcomm has their new AI 100s that they've released. And then so our software is really the bridge that abstracts away from one end to the other end. So you don't need to worry about where's this thing running, how's it running, how do I manage it, how do I update it. We're trying to be that bridge. And so it consists of, again, this inference engine, which is highly optimized software that runs in any cloud, edge, or on-prem location. And then we have our operations center, which then kind of manages all those running inference services, microservices, so to speak. And then we have our integrations toolkit then, which will integrate into, whether it's Azure ML or Azure data sources or whatever it is, IBM Cloud, etc. Right? So these are the three main components of our inference platform. And the idea is you're a data scientist, you're working in Azure ML, you've got maybe some kind of AI use case where you've got one model that transcribes speech from an audio recording. You got a second model that detects sentiment. You got a third model that just decides based on that sentiment to make a follow-up call to a potential lead, and those three have to work together, and you have to do it at scale. You have to do that millions of times a day. So you've got that on the one end. What we do is we give you that tooling, that SDK, Python SDK, that API, the UI that allows you to, in basically minutes, take that, wrap it up, and say, you know what, let me try and deploy this on NVIDIA, or hey, let me take, instead of NVIDIA, let me try it on ARM CPUs in Azure, or hey, now I got to move this over to on-prem, and lets you do that without having to worry about all that infrastructure complexity, and at the same time kind of optimizes how that's working. So one key aspect that our partners and customers love is what we call our auto packaging. And again, this is really around how do I package up this inferencing workload that I have to do for whatever target environment, whatever target model there is, and get it ready to be stood up. And so instead of, often like if you're doing this with, say, NVIDIA Triton or some open source solutions, a lot of times there's a lot of engineering work involved to get that packaging done, to create a container, to make sure it's fine-tuned and optimized for the hardware. Sometimes you do it once, it doesn't really work in the way that you expected. You have to go back and tweak it and try it again. There's some validation. So what we do is we eliminate all of that with what we call our auto packaging. So basically, with a few lines of code, you say, here's my set of models that I need to deploy. Here's my runtime. And then there's, three approaches that we take. One is, hey, I can take this PyTorch model and I can export it to some format like Onyx and run it on Onyx runtime. And then this Onyx runtime, I have an optimized Onyx runtime for this ARM infrastructure. And these are the configurations. We do all that behind the scenes. We literally do it in seconds or minutes. And then sometimes, you want to put some kind of custom runtime. Maybe you need to package in, it's a generative AI model. And again, you're trying to run it on a CPU. Maybe it's good enough for you to put that onto Llama CPP and run it there, or in other cases, there are folks that we're working with where you effectively recompile. There's a sort of compilation phase in taking that model, and you end up with something at the other end that you have to then integrate into that library and that acceleration libraries and the runtimes that get packaged into the hardware, right? So again, our goal is to look at that stuff, figure out, okay, what's the best way to do this, do all the configuration, do all the packaging, and give you something that you can stand up in either as a container or a Kubernetes Helm chart in literally seconds or minutes, right? And so as an example of this, let's say you had a Llama model, 8 billion, doesn't matter if it's 8 billion or something else, but you had it working on A100. Now you want to reconfigure it and get it work in optimal fashion on H100. So what we've seen is it can sometimes take a day to package it up, turn the dials, figure out what the right configuration is to maximize throughput or minimize latency. In our case, basically, again, it's a couple lines of Python, and we will get that custom microservice switched over from an A100 to H100 in under 5 minutes, right? So this is again a productivity boost for folks, number one. And number two, it allows people that don't really understand the infrastructure, whether it's a data scientist or somebody else, to basically say, you know what, let me make a quick change to this config and let me see how well this will run on a different architecture versus, maybe I'm going to compare NVIDIA GPUs to AMD GPUs, for example, right? And so you don't need to do all that extra effort. So that's one big goal. The second big thing is just the performance. So again, as I mentioned, we've really spent a lot of time optimizing our inference engine. And just to give you a sense of how optimized this is, these are benchmarks with Llama 8 billion. We've done this with the bigger models. With the smaller models, it's essentially the same kinds of results. But here it's deploying these models on NVIDIA Triton. Triton is NVIDIA's inference server software, right? On NVIDIA GPUs versus packaging and deploying with the Wallaroo inference engine on the exact same NVIDIA GPU. And the key thing, we when we do these benchmarks, we look at things like latency, we look at things like throughput, we look at things like duration. But the main thing to notice here, this is on NVIDIA H100s, and there's details around this. But basically, the main thing to notice is that we can get 2.4x better throughput on that same NVIDIA GPU using our software stack versus the standard thing that most people would be doing with the Triton inference server. So 2.4x better throughput with effectively the same latency. So 1.6 in this case for a single query, 1.6 seconds if you use the Triton versus 1.77. And so that demonstrates significant performance improvements, and this is all improvements based on tricks that we have implemented within our inference software, and having worked closely with our customers and partners, but also having spent a lot of time in different areas like high performance computing or high frequency trading. And this extends beyond just the NVIDIA architecture. So we have partnerships with Intel, Oracle, IBM. And these are actual numbers that we have published blogs with our partners on these results. But on Intel with our software stack, we've seen up to 4 times better. Obviously, depends on the model. Some of these models are computer vision models. Some of them are generative AI models. We usually test with a mix of models, but we've seen anywhere from 4x improvement using our software stack on the inferencing side to roughly about 2, a little bit over 2 on IBM and NVIDIA. So this is not just specific to NVIDIA, but we've seen these kinds of results across hardware architectures. And the great thing is then you can basically say, let me change the configuration. Let me try it on how this works on, Ampere ARM CPUs in Oracle, or let me compare how this thing works on Intel GPUs, or let me compare how it works on NVIDIA, etc. Right? So it gives the end user a lot more flexibility as well. And sometimes also, especially NVIDIA chips are not GPUs are hard to find. Let me just do a couple of use cases. So this is one of our customers, Extreme Reach. It's a marketing firm, and they have some of the largest brands in the world that they work with to deliver highly targeted ads, these ads are very much personalized, using multiple types of models, including LLMs and sort of multimodal implementations. And what we found, with these customers is, again, higher productivity on their data scientists and ML engineers and ops people, significant reduction in their deployment and orchestration costs around the people overhead and the actual infrastructure costs of deploying these things, and much better rapid scaling of newer use cases without having to throw engineering at it. Another example, unfortunately I can't name them, very well-known, very large life sciences company, and they're rolling out 4,000 what you might call AI in a box type solutions. So our partner here is Intel, And the idea here is that you've got medical devices and scientific devices. You're going to take the data off these devices. It's on the edge in the lab itself. You're going to take the data off these devices. You're going to run complex AI workloads. So, for example, you might have a digital, image of blood cells, and you're going to, instead of a lab technician or augmenting a lab technician, the AI inferences is going to basically mark which of these cells is infected or dead versus healthy or living, and you're going to do that in 80 seconds or a minute versus hours. And so you need the ability to run these very locally in a constrained environment. You don't have an entire cloud that you can scale out to, so it has to be highly efficient. But you also need the ability to manage that fleet of models from a centralized location. And actually, these guys are also working with Azure. So the idea would be, hey, I train in Azure, and then I need to go out and I need to deploy these models or update the model that's already out there in this lab environment. And so it's really like an appliance. And we're seeing more and more of that. One of our other customers is the Space Force. And that's also, train in the cloud, deploy into the edge. It's about as edge as you can get. We're actually going to be launching, beaming. It's kind of cool. We're going to be beaming models into satellites while they're already in space. So instead of like taking a model, installing it as install software before the satellite launches, and then having it as a fixed thing that you can never change, this is a very dynamic solution which is able to beam up models, run computer vision and other IoT type data models in real time on this very high resolution data on the satellite, and then beam down results. And so, this again shows you the flexibility of kind of what we built. But at the same time, we're working with a very small AI team that they have. And so effectively, they don't need to worry about all that infrastructure complexity of how that whole thing happens. They focus on making their business work and making their models as effective and as valuable as possible. So that's the actual slides. Gabriel, should I pause here, or should we just go straight into the demo?
Oh, let's go through the demo. I'll have some questions, and this again the chance for the audience to ask questions in the meantime. So let's see a demo, and then I'll see if we have some questions. Otherwise, I have a bunch of questions.
Okay. So I think actually one of our colleagues, Martin, is going to do it. Yep. So Martin, before you start, let me just set up what people are going to see. So this is some of our tooling, and we're going to be showing a data scientist working in a Python notebook, maybe in Azure ML, I'm not quite sure here, but we can pretend that's the case. And they're going to be basically working in the Python notebook, and they're going to be doing what they do. They're working with simple Python language functions and interacting with Wallaroo directly through the Python language. And what we're going to show is them taking a computer vision model. This is for a retail use case. So you want to basically look at what's stocked on the store shelves and figure out if things are misstocked, like you might have milk where the soda is supposed to be, or something else, or you got Coke where the Pepsi is supposed to be, or like there's inventory that you need to restock, right? And so what we're going to show is that model being uploaded into Wallaroo, being deployed, and then once you're sure that it's working locally in the cloud, we're going to show how you basically take that, and again, with just 1 or 2 lines of Python, wrap it up, package it up, get it ready for deployment in the stores or themselves on the edge. And then how you can bring some of that data back and look at it within the Azure setting in a centralized spot. Unfortunately, it's a little fast, but hopefully that gives you enough context that we're doing this all from a notebook, but it happens both locally in the cloud, but then it happens remotely. But as far as the data scientists or the ML engineer is concerned, they can control all of that from this notebook that's their primary source of interaction in this case. There is a API as well that you can do this programmatically if you want to just have software that interacts with it. There's UI, etc. But we're going to show you kind of like the data science viewpoint. Okay, thanks, Martin.
Steve with the field engineering team here at Wallaroo.AI, and today we're going to take a look at how the Wallaroo platform enables edge deployment as well as centralized logging and drift detection on those edge deployed devices. For this example, we're going to be taking a look at a computer vision model for object detection in a retail context, something that would be used for inventory tracking, for example. First, we import our Wallaroo SDK and make a connection to our Wallaroo instance. Next, we can do an initial test of our pipeline by doing a small-scale deployment in the cloud. In order to do this, I walk through the usual steps for a Wallaroo deployment, including uploading the model, configuring the deployment configuration, which specifies the hardware to be made available, and actually constructing that into a pipeline and deploying it. Now I can run a sample image through my pipeline to ensure it's inferring as expected before I go ahead and extend this to the edge. I run the image and I can see the boxes, classes, and confidences as I expect, and I can do a quick plot on top of the image to validate these results. I also have a fully functioning endpoint here that I can send more data to for additional testing or to just use it as a regular cloud deployed pipeline. Once I've validated that my pipeline works as expected in my sample cloud deployment, I can go ahead and extend this to the edge. The first step to take here is to call the publish function, which is essentially going to make my edge deployment self-contained. It's going to package up the engine and my deployed version of my pipeline to make it available to me. Next, I can call add edge and give this a name. This will essentially go ahead and register a deployment for a specific edge device that I'll be able to use for my logging and observability. The output here is going to give me a few important pieces of information. The first two are the pipeline and engine URL. Those are going to be the same across all edge devices for this publish. It's going to correspond to that particular pipeline, as well as an edge bundle. This is going to be the unique key that identifies this as this particular edge device, in this case, store 23, that is going to be tagged for any data that comes back for logging and observability. Now I can switch gears from the data scientist making this model available to the ML engineer who is actually responsible for deploying this on the edge device. So I have two terminals open here on my edge device. The left meant to represent the process of running this Wallaroo deployed pipeline itself. We can see here that this is a Docker run command that contains my registry information, my pipeline and engine URLs, as well as the edge bundle that's specific to this device. The right mimics an application that is going to make use of this edge deployment. And so when I execute this Docker run command, that's going to go ahead and start up this edge deployed pipeline. And we can see here that it's now up and running and ready to accept inference requests. In order to see this data point in the central logs later, I'm going to quickly capture the current timestamp, and then I'm going to run this sample image through my edge deployed pipeline. I can see the results here, and now I can switch back to my Jupyter notebook and see the logs from this inference request. In the logs, I can see the inference results as expected. And if I look at the metadata, among other information, I can see the edge location from which this inference result came. So what we can see here is that my edge device completed the inference request and successfully transmitted the logs back to my centralized operations center. And this centralized logging across edge devices also enables centralized observability. And so if I look at my assays here that are automatically screening for drift on my input and output variables, these data points are automatically aggregating inferences from across any cloud and edge deployments for this pipeline. Wallaroo also gives me the ability to break out these drift detection results by specific edge deployed locations or groups of locations. So today we've seen how we can extend our deployments to edge devices while also maintaining a centralized way to log and observe the behaviors of my edge deployed pipelines over time using Wallaroo.
Okay. Gabrielle, are you there?
Thank you, Vid, for the demo. Thank you, Martin, for the demo as well. This is very, especially again, as a data scientist, great to see like how you can leverage the tools and go back and forth and see your results in a fast and easy manner. And one of the questions that we got, Vid, in the chat, which I can take, or you are more than welcome to take, someone is asking, how is your product compared to Azure Foundry? Is it that it provides more hardware flexibility, where Azure is limited to its managed compute? Do you want to take that? I can take that as well.
Yeah, why don't you go first, and then you can take a stab at it as well.
Yeah, I see Wallaroo like more like on the hardware flexibility and different diverse deployments. The Azure AI Foundry, and for people that don't know, the Azure AI Foundry is it provides this managed integrated platform for AI development, and it focuses on the easy use of managed computer resources. So it's a little bit more in a way can be a little bit less flexible. Where Wallaroo, you can also deploy in different clouds and using different providers and connecting different pieces as well.
Yeah, I'll just add to that. I think we're not trying to, our customers actually use a variety of things. They'll use, Azure Foundry, or they might be using AWS SageMaker, or they might be using, and then they use us in addition to that. And again, I think they have use cases where it doesn't quite fit into that kind of prepackaged more templatized kind of approach. And so we're highly flexible, and so it allows them to kind of do these things in an easy fashion, which are outside of the kind of box with some of these other solutions.
Great. And one other question that I have, since we are talking about Microsoft and we talked about all the partnerships that we have, I'm curious, I'm always curious, especially as a startup, you don't have enough resources as a big enterprise company and visibility and exposure to clients and so on. Can you talk a little bit about this partnership with Microsoft? Like, how did it help Wallaroo scale and grow and go to the next level?
Yeah, I think there's a few things. One is credibility. Just, I think I remember when Microsoft invested in us, they said they were actively looking to invest in this sort of space, and they had talked to 20 or 30 different startups before they invested in us. So I think having Microsoft invest in us is credibility, and other partners and other customers, like that's a really important badge to say, hey, Microsoft, who's kind of one of the gorillas in the space, has kicked these guys around and they survived. So that's really important. The second thing is really, I think, visibility. So we're part of this Microsoft for Startups program, and I think in particular, I think they call it Pegasus. And so we get some nice goodies out of that. So we get to turn up in Microsoft booth or presence at different conferences. So like late last year, we went to Shop Talk. I had the regular person that goes there couldn't do it, so I ended up going. I got a few days in Barcelona. I'm not going to complain. And hung out there and got to meet maybe 30 different retail companies. And then actually next week, we're going to be part of Microsoft's presence at NVIDIA's GTC. So that's really, like for, again, each one of these things saves us like, $10,000, $20,000, which as a startup, you not only get high profile visibility because people are going to Microsoft's, I wouldn't call it a booth. I don't know what you guys call it, but your island. And so being part of that is great. And it also allows us to spend our marketing dollars on other things that, otherwise we'd be spending on that. And then the third thing is really getting access to the Microsoft go-to-market and sellers to kind of explain what we do and and see if we can get customers, going that way. So yeah, I would say those are the kind of three key things that it's been great, having, apart from just having the Microsoft money in our bank account.
No, absolutely. Yeah, it's definitely more, I say it's more than credits. Credits are great, but there is a lot of other things that you can take advantage as go to market, and then a lot of visibility opportunities. So NVIDIA, it's the conference that is happening next week. It's thousands and thousands of people being there and seeing what is the next big thing. Another question that I have is about going back to the demo, and what you mentioned is about the LLM performance management. So I think you have LLM listeners.
Yeah.
Is that what you call?
Yeah.
Can you just
Yeah, so we
explain
have
a little bit
Yeah, so we have a pretty extensive framework for managing, monitoring the production inferencing. And so in addition to pre-built things, like some of the stuff that you saw in the demo, we have the ability to deploy lightweight generative AI models to monitor either in real time or in batch your primary model. So let's say you have some kind of customer support model, and as everybody knows, sometimes these things will go a bit crazy, and so, for example, you might be looking for toxic language. If, for example, the customer speaks to the model using inappropriate language, the model might react in a way that you don't want it to respond with, and things like that. So we have the ability to basically monitor this stuff in real time using, I might want to look for things like accuracy. I might want to look at toxicity or bad language, or correct, like domain appropriateness, like this, response has to make sense within this domain. All sorts of things like that. So you can take the primary model, you can package it up with a bunch of other listeners, as we call them, deploy that all as one pipeline, and you can either use it reactively, meaning you can try and then understand where your models need to get improved. You have all the data there to help you like retrain the model or fine tune the model. But then at the same time, you can also use those listeners proactively, meaning if you flag something that is just not good enough to respond, then you can real time in that chain of responding, you can opt to do something else, right? So maybe you take that and you send it to another model, or you give a canned response or whatnot. So that we have a lot of flexibility in terms of how you can deal with these things.
Great. And we have a few minutes left before we wrap up. For people that are interested in knowing more about Wallaroo, what would be the best call to action for them to learn more about the product? And I see that there is a community edition as well, where people can try for free.
Yeah. So let me just, this is my marketing department said I have to share this last screen. So let me just do that. It's got a couple of links, and then I can talk about it. Okay. Oops. Let me go there. There. Okay. Can you see this?
Yes.
Yeah. Okay. So there's obviously the website. You can go to Wallaroo.AI. If you want to look, we have very extensive collection of blogs, both from a business use case perspective and a technical perspective. So you can go there as well. There's technical documentation like the API and the SDK documentation on these websites. And then there's forms that you can fill in. If you decide, hey, I want to see a demo, like around my use case, I have this specific use case, I want to explore further how to use this thing. Either you can contact us through one of the forms on the website, or use info@Wallaroo.ai. But yeah, there's multiple ways to get in touch with us.
Perfect. Thank you so much. And I know that there is also the YouTube channel. There is a lot of great videos over there. So if you're interested in knowing more, you can go to the YouTube channel from Wallaroo. We'll share the link in a few minutes. And Vid, now that things are moving so fast, I'm interested in like listening to your take. What is coming next? What is the trends? What is the next thing in the whole AI? And maybe in your space, where are you seeing Wallaroo going next?
Yeah, I think big thing that we're seeing with our partners and with customers is a desire to do two things. One is multimodal models, or kind of simple agentic AI, not go down the total crazy stuff, but start with something similar that they can get working. And the other thing that we're seeing is a desire to, especially the generative AI can be very expensive. Is there other infrastructure option? Are there other infrastructure options that we have to? Because the standard is to just deploy the NVIDIA GPU. So in the short term, we're seeing a lot of interest around those two areas. I think longer term or midterm, we're seeing the emergence of on-prem and edge as huge growth areas. I think those things are going to, and it's never only cloud or never only on-prem or whatever. It's going to be kind of cloud to on-prem or cloud to edge. So we're seeing a lot of use cases like that that are now reaching kind of the interest of customers. Longer term than that, I think I don't know. I'm not going to hazard what it is, but I do think we're very well positioned because for AI to be effective, you have to operationalize it. And you have to operationalize it in a way that you can manage it and you can monitor it and you can keep it effective, right? So that's what we specialize in, and so I think we're excited about what the next year or two happens. But we're also, I've told everybody in the company, if you think here's a 1-year plan and we're going to march to this 1-year plan and that's the way it's going to work in this landscape, then you're wrong. Right.
Yeah, there is no way to do like a 1-year plan anymore. It's like a 2 months plan. It's things are moving so fast. So Vid, I know that we are on time here, but I want to thank you so much for being here with us today to talk about Wallaroo. Very excited to see what the product is coming and going and doing. I hope you had a good time here with us today, the audience that's watching us. So thank you so much. I'll see you next week at the NVIDIA conference. And before we wrap up, the audience, I want to share again that this show happens every other week on Thursdays at 9 a.m. here on YouTube. Same link. You can register, get notifications. And after every program, we send you an email with like great resources. So thank you again. And I see you next time in the next show.
Thank you, Gabriela.
Thank you.
Thanks for having me.